Stars have been shining for billions of years, but the universe is not eternal. Eventually, even the brightest stars will burn out, galaxies will fade, cosmic light will dim, and the universe will slowly drift toward silence. Understanding the last star gives insight into the final fate of everything: planets, galaxies, and even life itself. The story of the last star is a journey billions of years into the cold future of reality. Stars are born from clouds of gas and dust. Gravity pulls atoms together until nuclear fusion ignites. Over millions or billions of years, they shine brightly, but every star has a finite lifespan determined by its mass. The most massive stars burn fast and die young. Smaller stars like red dwarfs live far longer. As the universe ages, only these faint, slow-burning stars will remain. Red dwarfs are the universe's last survivors. They burn so slowly that even after trillions of years, they will not exhaust their fuel. These stars are small, cool, and faint, invisible to the naked eye from distant galaxies. Yet they hold the key to the universe's final chapter. The last star will be one of these dim red dwarfs, shining quietly long after everything else is gone. As galaxies evolve, star formation declines. Gas is used up, expelled, or locked in dead stars. The universe becomes darker. The Milky Way will merge with Andromeda and other local galaxies, forming a massive elliptical galaxy with little remaining gas. Star birth will become increasingly rare, and the cosmic night will grow colder and emptier. Eventually, only long-lived red dwarfs will burn. Even the most massive stars will have ended in supernova or collapsed into black holes. White dwarfs, neutron stars, and black holes will dominate the galaxy. Light will be scarce, with only faint points of red light marking the final stars. The universe's energy landscape will shift toward darkness. Red dwarfs are remarkably resilient. They can last for trillions of years, far longer than the current age of the universe. Unlike larger stars, they burn their fuel efficiently and evenly. The last star is likely to be a red dwarf quietly fusing hydrogen into helium, unnoticed by any observer, far beyond the lifespan of planets and civilizations. As trillions of years pass, even red dwarfs will evolve. They swell into faint white dwarfs and gradually cool. Eventually, they will fade into black dwarfs, cold, dark remnants no longer producing light or heat. By this stage, all visible stars will have disappeared, leaving the universe a dark, empty expanse. Planetary systems around these stars may survive long after their suns fade. Planets become frozen orbits around black dwarfs. Any remaining life, if it survived, faces extinction. Without energy from starlight, chemical processes cease. The universe becomes inhospitable, silent, and cold. The last star's death marks the end of energy flow necessary for life. Even black holes will slowly evaporate via Hawking radiation. Massive objects lose mass over unimaginable timescales. In trillions or quintillions of years, remnants of collapsed stars vanish. The last sources of concentrated matter and energy disappear, leaving only sparse elementary particles drifting in dark space. Cosmic expansion stretches space relentlessly. Galaxies recede beyond the cosmic horizon. Light from distant stars fades forever. The universe becomes isolated, each region cut off from others. The last star may shine alone, unseen from anywhere else, in a universe increasingly empty and cold. Eventually, the universe reaches the heat-death stage. Temperatures approach absolute zero. Motion slows to nothing. Energy differences that powered stars, planets, and chemistry vanish. The last star may have already faded, leaving only darkness. Space stretches infinitely, but it is lifeless and silent. This end is not abrupt. The death of the last star is a slow fade. Over trillions of years, light dims and energy dissipates. The universe does not explode. It cools and fades. Time stretches in vast emptiness. The cosmos becomes a quiet, frozen expanse, with no visible structure remaining. Even in this darkness, physics continues. Particles drift, rare interactions happen, black holes radiate, and virtual particles appear and disappear. The universe persists as a collection of matter, energy, and space, but without observable stars. The cosmos survives as cold emptiness, not a place of life or light. The final chapter of Stars teaches perspective. Every civilization, planet, and galaxy is temporary. What seems eternal today, the night sky, galaxies, or the sun, will one day vanish. The last star is a reminder of impermanence, an endpoint to the luminous history of the universe. The universe will eventually be dominated by dark energy and black holes. Empty space expands endlessly. Stars, the architects of light and life, will vanish. What remains are traces, cooled remnants, faint radiation, and particles drifting in infinite darkness. The cosmos becomes a silent tomb. Ultimately, The last star signifies both an ending and the incredible longevity of the universe. From the first spark of the Big Bang to the dim flicker of the last red dwarf, the story of stars chronicles the rise and fall of light. After the last star dies, the universe will continue, but in eternal darkness, an empty testament to everything that once shone.